Friends, welcome back to my channel. I have this Arduino Uno. How we can take 5 blinks and then it will stop. When we change any conditional input, for example, this is now ground that is connected to pin number 11, digital read. When I will change this signal, I remove the signal. Now it is pulled up. It is blinking 5 times. And after that it will stop. When I will change the condition again, it will blink 5 times again and it will turn off. Basically it is a question from my viewer. He sent me this circuit diagram. It is using Atmega 328 microcontroller. This is basically to protect DVR system against power failure. If anyone will come in any security system and he want to turn off the DVR, this circuit will intimate the power supply for the camera it has been stopped. In my last session we discussed how we can write a code to operate this K2 relay, that is battery charging control. But K1 relay, that is the important relay, it will detect the power failure. If there is no electricity at that time, this optocoupler will turn off. When it will turn off at that time, pin number 17, that is PB3 input, it will high. When it will high, at that time this microcontroller will generate a command and it will give 5 times warning on this relay, because it is a requirement from my viewer. He sent me on the WhatsApp.
जी भाई उसने 5 दफा ऑन ऑफ होके तो बंद ही रहना, ऑन नहीं होना। जब भी वो होगी उसको सप्लाई मिलेगी तो भी वो 5 बार क्लिक करके ऑफ रहेगी, और जब सप्लाई आएगी तो भी वो 5 बार ऑन ऑफ होके ऑफ ही रहेगी।
It is a condition that if the power is failed or the power is recovered, in the both conditions this relay have to toggle 5 times and then it will remain off. It is his requirement. So we write the code. This time the electric is failed because I removed the ground, which is controlled by the optocoupler. When the electric is available, the optocoupler transistor is switching. At that time it will provide ground to pin number 11 of this Arduino board. It is using PB3 and PB2 from this microcontroller because he is using Atmega 328 IC alone. So let's see in the Arduino board, PB2 and PB3 are connected to this 10 pin header at pin number 10 and 11. So pin number 10, that is connected to PB2, that is output pin, and pin number 11, that is digital read pin. So let's start how we can write the code. First of all, we will create the circuit conditions and then we will continue it step by step. We can use optocoupler. This time I am using 10 kilo ohm resistor to pull up pin number 11. First of all, we will connect pin number 11 as an input. So here we have pin number 11. The second end of this resistor we will connect to the VCC 5 volt to apply pull up voltage. So here we have 5 volt. Now we want to connect the ground. So here is a DC rail for the ground. We will take ground from here. We connected the ground and we will make a jumper here to pin number 11 to give ground pin. So ground is coming here and then it is reaching to this pin and it is connected to pin number 11. Anytime we want to remove the ground, we will disconnect from here. Okay, now we will connect LED cathode as a display monitoring to the ground, and I am using 1 kilo ohm resistor. You can use 330 ohm resistor. This time I am using 1 kilo ohm resistor and I am connecting to the output pin, that is pin number 10 of this controller. So this is the circuit condition, and now I will connected to the computer port. Yes, it is working. First of all, see the circuit, pin number 17, PB3, that is in Arduino board, that is pin number 11. We will say pin number 11 is being used for electric detect input pin. It is to detect the electricity. We will give the name exactly which is matching to the function. So we can understand very easily, declare it here, integer electric detect, that is pin number 11 in the Arduino board. Pin number 16 is driving the K1 relay, that means it is output pin. Integer, we will say it is relay drive. Relay drive, that is pin number 10. Terminate it. In the front of this pin, write the pin function. It is to detect the electric. Pin 10, it is to drive the relay in case of electric failure. Now come to the setup. Here we will define the pin role, either output pin, input pin. So pin number 11, that is input pin, because we are reading something from this pin. So we will say pinMode electric detect, comma, it is input pin, bracket close, terminator, pinMode relay drive, comma, output, terminator. This is our definition, that this pin is input, this is output, pin direction. Now in the program body, what we will do, now we need to measure the voltage, from where we need to check pin number 11. We will define a name here for our measurement, because we are going to measure something. Electric status is equal to digital read, from where we want to read pin number 11, that is electric detect. Paste it here, terminate. Now we defined something here, anything which we want to use for our easiness, we will write it here. We will define it here, integer electric status. Normally we can say it is low. The initial condition, it is low. Or we can write high. Now we defined something, that electric status is equal to digital read, that is electric detect. Now we will use if and else function. If else, if, what if electric status is equal to low or high, whatsoever, what we can say, digital write, what to write, where to write, relay drive, comma, high, or we can say low, whatsoever, what we want to do it. Otherwise, copy it and paste it. If the pin number 11 is low, that is electric status, if it is low, the output relay will high, otherwise relay will low. So this is our program. We will say it is 111, whatsoever, it is test program. So program is compiled, there is no error, upload it. We upload to the program. Now the light is on. When I will remove this signal, LED will off. As we defined here, if the pin is low, LED is high. We can also connect relay module so we can see it practically. This is the ground line, and here we have the signal. Yes, it is working. Now we have condition. Electric status we defined here, but now our condition is some separate. We want to detect the electricity. When the electric will go high to low or low to high, at that time we want to test the status, because we have two conditions. Either the light will active available or it will miss. In both cases it have to toggle 5 times. Okay, now we need to reconsider this area. We want to know what is the condition, either light is present or not. We will define global variable byte. It is to detect the logical change, last electrical status. We defined here last electrical status, copy it, and here when the system will turn on, it will know what is the status in the initial startup. Last electrical status is equal to, what is equal to? Digital read electric detect. Now we said when the circuit will start, it will store this condition. This is the last electric status. It is digital read from pin number 11. What is the condition? Either when we powered it on, either electric is available or no. Now we will change this portion here. Now we will delete. We set last electric status, that is digital read from electric detect pin. What is the condition? Now we will read again. Now we will create another byte function. Current electric status, that is equal to digital read where the same electric detect pin. This statement will run at once when the circuit is powered on. So it will store the condition that what was the condition at startup. Now in the loop it will check every time what is the current electrical status. So it is our new byte function. It is now logical operation. Now we will use if function. Current electric status. Point to understand, current electric status is not equal to the last electric status, bracket closed. Now we created an argument here. If current electric status is not equal to last electric status, what it will do? Last electric status is equal to current electric status. Terminator. You can say, what is this? This is very understandable point. Let's repeat again. We created this argument that when the circuit will start up, at that time it will check what is the condition of pin number 11. Now when the circuit will power on and it will run again and again, every time it will use this global variable. It will check all the time the condition of pin number 11. Now we said if current electric status, which we read here, not equal to this, what processor will do? It will change the last position, last electrical status with current. What is the current status? That is here. Now create another argument. If current electric status equal to, we will put double equal sign, copy it, bracket closed, braces. We set if current electric status not equal to this, change the new status, last electric status with current status which is here. So when it will repeat again, it will not consider this status. Now it will update all the time with this one, which it will read, it will store here. If it is equal, it will not change anything. If it is not equal to both, here we can now create counter function. Here we can increment function. But now I will write here very simple, in simple way, digitalRead what relay drive comma high. It will turn on the relay. Delay period terminator. We said delay period. We can write here millisecond, but it is best way to define the delay here in the top. So anytime we need to change any delay period, we can say it is 500 milliseconds. Anytime we want to change the interval, we will no need to change all the program. We will just only change these numbers. All the program will update it automatically. Copy this statement. We can also write increment function here, but our program is not too much long, so I will write in this way. There are many approaches. This is one block, one function, 2, 3, 4, 5. We repeated 5 entries. Our program is now complete. Compile it. Yes, it is done. Now we can upload. Yes, it is uploaded. Just remove the ground from pin number 11. After 5 toggles, it will turn off. Switch on again. Connect the ground again. It will toggle 5 times and it will stop. I will remove the ground again. Anytime we will change the position of this pin number 11, that is digital read pin. Anytime digital read pin will change, it will cause to toggle the output 5 times. Every time it will update its last status with the current measurement and it will switch. For example, I want to change the time here. I will just only change 1000 and upload. Now all the program will change automatically with 1 second interval. For example, I want to toggle it more times, 10 times. Okay, let's check it. Now I sent code for 10 times, 10 toggles at one click, at one change. Yes. If we understand this function, we can do everything whatever we want. In the initial startup, we wrote a command that it have to read the input pin, that is pin number 11. When it will read, it will store the data as a last electric status. What was the condition? Light was present or no? Now the second byte function, it will check this pin again and again. Here we checked first time in the startup, and here it will read again and again. When it will read at that time, it will say current electric status. This was the last in the initial start, and it will update it all the time. When we say what is the measurement now, it is known as current electric status. If current electric status is not equal to, this is not equal to. If there is a difference, what to do? Because here we are calling if function. What to do? Last electric status is equal to current electric status. This was the last status. We said update this status with this one, so it will change this condition. Now if there was some change, if current electric status is equal to last electric status, because we are calling if function 2 times. If there was difference, then do this, after that do this, and finally we closed all the braces here. Now we will change the time here 400 millisecond and upload. I will change the position. Now I will change the pin status, that is current electric status, again from low to high. High to low, low to high, high to low. Anytime we will change the pin status, pin number 11, if it is high or high to low, at that time it will turn on, turn off again. Let's monitor the pin. This time pin number 11 is low. If I will pull up 4.9 volt, it is switching now. When I will pull down again to ground, it will switch again. I hope so you enjoyed this video. If it is good, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.